Hello, everyone, and welcome. We will get started in just a few minutes, but before we do, if you would like to introduce yourself to everyone in the chat box, you can say your name, where you're calling in from, and where you teach or what you teach would be great. Thank you. Just to get started, I am Nikki. I am work in the education department at WGBH, and I help do a lot of the outreach for Design Squad. Robert, if you would like to introduce yourself.
Sure. My name is Robert Parks. I'm a senior editor at WGBH, and my work involves developing the activities that we have for Design Squad, and I do that in collaboration with Nikki and other folks on the team.
Yeah, we'd ask if you all could stay muted during this webinar. That would be great and help prevent background noise. And we'll be using the chat box for most of our communications.
Hello. I can't.
All right, great. Thank you so much for being here with us. We've got a few more people joining. We will get started in just a few minutes, but if you would like to introduce yourself in the chat box, you can add your name, where you're calling in from, and what grade you teach. That would be great. All right, wonderful. All right, it looks like we've got a pretty full house and we've got a lot of stuff we want to get through today, so I think we should get started. Welcome and thank you so much for coming. We are going to be talking about Design Squad today and some of our tips and tools for bringing engineering activities and practices into the home. Just a quick background, Design Squad originated as a television show on PBS Kids. It was a show that was aimed at showing kids engineering and getting kids excited about engineering. And that show has quickly evolved into a platform and a program through GBH Education. And what we do is we create resources, hands-on activities. We maintain a website, all sorts of things to keep people excited and engaged in engineering. With that being said, I'm going to kick it over to Robert, who is going to get us started for the first half of this webinar. So take it over, Robert.
Great. Thanks, Nikki. And thanks so much for coming, everyone. I know this is these are interesting times, but they're good conditions for our kids to start this kind of work. I'm sure many of you are familiar with the design process. Maybe if you'd comment in the comments about work you've done, I'd like to see that. But the design process typically involves engineering. And it is at the heart of our work. A lot of different programs and schools and curricula are involved with the engineering design process, and it's part of standards, but we have our own take on it. Nikki, would you forward the slide? In terms of our own take, it's a pretty standard process of defining a problem. The child sees something relevant to them that they want to fix, maybe a lock problem at school, maybe something that is really annoying in the kitchen, or maybe a serious community problem that could be addressed by engineering and that they want to figure out a way to address it. And then they brainstorm solutions and plan them out. Planning and sometimes involves making a diagram, and they start to build. Kids love to build. So the building part is no problem, but the other parts kind of scaffold that, and it's a tool. The engineering design process is a tool that they can bring with them to other topics. Maybe they're not engineering inclined as they go through their pathway, but to plan something, brainstorm it, build it, and then test it and evaluate it. Realize that it's wanting, that you need to iterate, and iterate here means to kind of improve it or rebuild it with a different set of conditions, or change it so that it's better, or change the problem definition a little bit so that it fits what you really want to do, and then rebuild it. And engineers rebuild things, invent things a dozen times to get it right. And so this is a great thing to teach our children, that they fail and they can fail, and that professionals do this kind of work of being resilient to failure and trying things again. So our project often involves low-cost materials so that it's really easy to do in the home or the classroom. We do most of our work in out-of-school settings, and we're progressively thinking about creating curricula that work kind of turnkey in classrooms. But for now, it's in the home, in clubs, and museums and things like that. So it's a time for kids to learn the practices of engineering design and all of those things that I talked about and that many of you are familiar with. But for science concepts, it's a really great way to drop in a hands-on, because those are the three dimensions of learning are the cross-cutting concepts, the getting the hands-on, and the ideas, the science ideas, and bringing those all together. A lot of times educators are looking for those opportunities. So that's what kind of the things we're thinking about today. In terms of what you'll get today from our kind of 20-minute discussion, and we're hoping for maybe 5 to 10 minutes of Q&A. We want to give you some tools and ideas to help kids solve problems around the home and in their communities. We have a list of activities, a big list of maybe, I don't know what, Nikki, 30, 40, 50 activities that
yeah, somewhere around there.
Yeah, and then we're just going to highlight like 6 of them just to give you a taste of what the variety can be. And we're going to give you a copy of this slideshow so that you can explore the links as well. Nikki, next slide, please. One of the great things about about Design Squad is that our materials are free in terms of the PDFs and the guides and the resources, and we try to keep it very low impact in terms of recycled materials, free materials that you'll just find around the home, and no barriers in terms of your expertise as the educator or the parent. So it's really child-led. So they're defining a problem that they see, and they're motivated to solve that. And your job is to perhaps read some of our prompts to think about how to support them with open-ended questions, and let them do that work. And this is a perfect time for them to kind of struggle at home, like creating a prototype and maybe improving it, using different materials next time, things like that. It's the engineering design process has a really great benefit for child learning, but we've seen in our testing of these materials, and I've seen personally in my work with a high school class that I teach every Friday, that sometimes it takes a long time for kids to develop these habits, and they're great habits to have. So next slide, please. So let me show you a few of our engineering activities before giving it back to Nikki. Pop Fly is a great engineering activity that will help kids practice engineering design. And these subheads here, the engineering design, forces and interactions, structures and properties of matter, these are ones I lifted from the Mass State Standards and from the NGSS. And although, as I said, they're meant to be complementary with a lesson of those concepts, they really do give a great hands-on component to whatever's there in that subhead. So they're great topic of conversation for the child and the educator, or the parent and the child, to talk about the science concept. And we believe that they should have this experience of doing these activities first, and then hitting the science concept. So you have this activity before concept. It's ABC is one of the catchphrases around here. So Pop Fly, they're working with levers, and they use these materials to create whole divergent array of different ways to shoot a ping pong ball in the air. And one of the ideas, kind of the heuristics around Design Squad, is not to show the child the end result. It's the process that's important, and they may come up with a lot of very surprising incarnations of a ping pong ball launcher. A rubber band car is that old chestnut that we kind of put our own spin on. It's the rubber band as a source of potential energy that kids let go and make their car go. And maybe if you have a family with an older kid and a bunch of siblings, the siblings can work on a component of the car, or maybe all of the kids together can compete on how far they can get their rubber band car to go across the room, something like that at the end as a carrot. Next slide, Nikki, please. Wind power station is one of our activities in our new Inventing Green guide. So all of the 4 activities in that guide are involved with renewable energy, recyclable materials, engineering as a materials challenge, engineering as a way of looking at energy differently, those kinds of things. So it's a wind turbine activity, but as you see, the girl on the left, she's got a wind turbine made with cardboard, and the girl on the right is using a recycled bottle for the blades in her rotor, and they both come up with good solutions. And in the spirit of the design process, we're asking kids to think about how they would use the energy from a wind turbine. And increasingly in our world, we're using mechanical energy from wind turbines, kind of a throwback, so that there are modern agricultural uses for wind turbines that don't involve electricity. You could use it to lift something heavy in the community, maybe load a barge or grind grain, things like that. Our sneaker activity is a perennial favorite. It's the one on the right. The girl's showing a prototype of the sneaker. And what I like about our process and about Design Squad is, honestly, some of the projects don't look that spiffy. I mean, that is not a Nike shoe there that girl's holding. But they're so proud of it because they're invested in it. It's part of it's just a data point for them on a process that they know they're on to improve that project, and it's got their own spin on it. So it's something that they feel that they can really improve, and they're also learning a little bit of science along the way. So the sneakers project comes in with Newton's third law, where the materials talk a little bit about how your foot strikes the ground and that's a collision, and how are you going to slow that collision? You're going to use materials that are going to absorb that impact. And like a lot of sneaker companies right now, those foams are very bad for the environment, and they hang around the environment when you throw them away. So maybe there are other things around the household or other materials you can think of that would slow the acceleration of the foot against the ground with a safer, better material. Next slide. Helping Hand is another activity that talks a little bit about levers, but it's really an engineering design practices activity where the educator can show how a kid has improved their process of creating a machine that gets something down from a high height. So if you got an object on a shelf, and the child has this machine that it's like kind of a grabber, maybe you could have a competition among kids in a family or kids across the internet of how long can your grabber be and still be effective, and how heavy can it grab something from a high shelf using those materials like paint stirrers and things like that. Build a Better Lunchbox is an activity where kids keep a popsicle or some ice cubes inside a thermal insulator that they invent, and we're thinking about, like, what if you wanted to bring a popsicle for an early lunch at school? How would you do that? What kind of materials would you use to stop the heat from coming in to the popsicle? And next slide. And then finally, we've got paper table and flight test. Paper table is a cool one where we increase the rigidity of newspaper, if you roll it in a circle, and then you can create a truss by making a little triangle, and that's kind of the seat of a lot of structural engineering advances. And it also teaches engineering design where you make a platform and try to keep something heavy on it with just a few sheets of newspaper that you've rolled up in this special way. So it's kind of a fun surprise that these materials do that. And then flight test is also in our green guide. It talks about drag of airplanes. And airplane flight obviously is a big carbon generator. And so how can we create new modern designs, just like aerospace engineers are doing right now, to make less drag as it goes through the air. And it's a surprising one. It's good for a group of kids. You put up a thread across the room, and you've got some paper clips and a spoon, and the spoon gives it weight, and you put some wings on it to make it go faster down the string. And the surprising thing we found when we've tested this in classrooms and across different events and with different kids is that the spoon itself goes slower than if you put an aerodynamic wing on it. So I guess there's some lift there involved, but kids probably don't need to think about that, but that's sort of like more like the graduate level physics something, but they have a lot of fun with it, trying to change the configuration and iterate on those airplanes. So thanks, Nikki. Back to you.
Great. Oh, Robert, one more.
One more. Right. I just wanted to mention that, sometimes when we present to adults with these activities and we show the product, it's really process, not product. So the inventions that kids create are often quite innovative, but you have to look at them carefully to see the innovation. A lot of adults will say, "Oh, this is just tape and cardboard. What are you doing? They're just playing around. Let's do something serious with a more advanced kit type of project-based learning activity." And those are out there, and those are excellent. But we find that the low-cost materials have really paid off in a lot of different ways. It gives kids independence because they feel that they have to come up with something themselves based on that cardboard and that recycled bottle, or different things that they have available with them. It gives them agency because the materials aren't leading them towards a certain goal that somebody else has figured out. They're pursuing their own learning goals. And sometimes the kits that kids are working with, which can be great skill building activities, don't always give them that open blue sky opportunity to experiment and iterate on things that they want to do themselves. So go ahead, Nikki.
Okay, great. I'm now going to give a basic overview of where you can find all of the Design Squad materials, and then some ideas for ways you can have your students connect with one another, maybe while they're at home. So I'm going to start with the Design Squad website. This is our kid-facing PBS Kids website. This website has great tools to get kids kind of just starting to engage with engineering or kind of expand on their engineering knowledge. We have a series of short form videos which either feature a kid engineer who developed a really incredible project, like a water-saving toilet design, or one kid invented a robot that detects tiny pieces of plastic in water. We also have design challenges on here where we challenge kids to design things like create clothes that can be functional in all different kinds of weather, and kids draw their designs and submit them. Kids can also challenge each other to design things. My favorite is a magnet for puppies. I think that is an incredible design that I want in my life. There are also builds on this website for kids. They come in a photo essay format, a little bit easier for kids who might be working on their reading skills or might be English language learners. They can follow along with the pictures in this format. And then we also have our engineering games. things like, can you city plan for the fidgets, or can you build wind turbines to help power their city? They're just different challenges to get kids interacting with engineering in a bunch of different ways. I also wanted to point out our Design Squad Nation collection. This collection lives on PBS LearningMedia. As you can see, this collection is organized by science topic, and these are where you can find the printable handouts that are the activity guides. These also come with leader notes, which are great if you need help having a parent demonstrate these activities with their kiddos. This collection also features career profile videos that show what engineers do in the real world, and also short animated explainer videos that can kind of show a science concept that might be difficult or a little bit intangible, so kids can help kind of concretize their learning. Also, what's great about this collection is if you click on each resource, you will see the standards based on the state that you're living in, as well as the national standards that align with this. Align with this collection. Some extra supports for home educators. We know a lot of parents are being asked to help kind of support their kids in learning situations. So we wanted to point out some resources we have that can help maybe ease that for parents. Many of our activity sheets are accompanied by detailed leader notes. These leader notes have material list, they have science concepts explained. They also have even language and prompts to help with parents who might be uncomfortable with leading these activities with kids, so they don't have to overthink it or do too much prepping on their end. They can kind of just follow along to lead these activities. We also have a series of professional development videos on PBS LearningMedia that can help support people in teaching these activities at home. The videos cover topics such as what is invention, which just kind of asks parents, just explains what invention education really is. We also have a setting the stage for invention video, which teaches you how to kind of create an environment for invention, not just with what you have around the house, but also prompts you can use, language you can use to help promote inventive behaviors. And then we also have a video on environmental sustainability in engineering, and it kind of teaches not just how to create inventions that solve environmental problems, but also how to bring the process of sustainability into the practice of engineering and invention. Normally, I would play a clip from one of these videos for you quickly, but we are running out of time and I want to save time for Q&A, so I'm going to skip over the video. But like we said earlier, we will send out this presentation to everybody after this webinar, and you can go and watch that video on your own. I'm sorry about that. I know the videos are people's favorite parts. Our next resource I want to point out is our club guides. These club guides are complete kind of curriculum. They were originally intended for after-school programs, but they all have at least 4 hands-on invention challenges, 2 bonus challenges, again, leader notes, full material lists, club materials, and then a chance to help lead a student coming up with their own original invention idea for something they want to solve. These are great resources for just leading through a series of activities if you want to help set up kind of a more regular invention or engineering practice with your kiddos who are at home right now. And again, they have plenty of support. So if you have parents who are comfortable, there's still great supports in here for people who might never have done engineering or invention activities before. Another thing in these guides I want to point out is these guides were originally created with the intention that a US club would partner with an international club and communicate about the invention process. So there are already communication tools built into these club guides that you can use to help connect your students virtually right now. We have forms in the club guides, like review feedback forms, how to give a great presentation form, how do you specify what your design is form. So these can be great for evaluating the thinking your students or kiddos are going through during the process of engineering, but they can also help kind of maintain communication between your students during this time. If you want to have them give feedback to one another on their inventions, it can be really lovely. We have some ideas for ways to communicate with your students. I know everybody's been on Zoom calls recently. This is a Zoom meeting right now. but it's great. You can have up to 300 people on one call, and I think Zoom is free for up to 40-minute calls. Google Docs is another way we've seen people communicate virtually, where they will create a running document that different students can add images or writing to stay in touch. We've had a lot of clubs use WhatsApp because of international clubs tend to favor it because it's a free international tool. But even just emailing videos and pictures back and forth, you can have your students either take pictures of their inventions and then write out a description of what they are, or film themselves explaining what their invention is. These can be great ways to share with one another and stay connected during these times. If you have other ideas, please put them in the chat box. Everybody is learning and picking up new tips and tools right now as we go through the kind of new normal right now, and we'd love any feedback or any additional ideas. I know some people were worried about the information in the chat box. I can copy and paste it into a Word document and send it out with everybody along with the webinar, just to make sure everybody has that information. Okay, now we'd like to open it up for questions. If you have any questions you want to ask Robert and I, please feel free. We have about 5 minutes left. I also quickly want to point out some more resources. We have our Design Squad YouTube channel. Our host of Design Squad, Nate Ball, has been doing daily live videos where he does a build along, so you can tune into those and build along projects with him. Here are all the other websites I also mentioned earlier in the webinar, and we also have a full PDF list of all of our Design Squad printable activities, and it tells you what languages each activity comes in and directly links you to that activity. That way you don't have to go hunting for them, and we'll send that out after this webinar as well. All right, let's open it up to some questions. I see the first question is, what grade levels are your activities designed for? We say our sweet spot is between middle school is usually what we intend for, but we've seen people usually do upper elementary as well. Would you agree with that, Robert?
I would, and in terms of opening up the design process to more ambitious projects, we kind of go over those in the 12-week guide. And I have had some success with my high school students, just working with tape and cardboard and envisioning things that they need for their lives. And so the kind of things can be airdropped into other grade bands, but definitely middle school and 3-5 is the sweet spot.
Great. I'm seeing some other questions come in. Can we use the Design Squad name? Please, we'd love for you to use the Design Squad name. We're all Design Squad team members.
Also, I saw somebody asked a question about non-visual learners. There's an educator at a deaf school, and most of our videos are closed captioned. So all of them are. Yeah. Right. Good.
Yep. Both on YouTube and on our PBS Kids website and on PBS LearningMedia. Yeah. Can you share more about the international connection aspect of this project? Yeah, we were very fortunate in the original inception of Design Squad. We created these clubs with the intention to have a club in the US exchange with an international club. And we were really fortunate. We were able to do that for about 4 years, but unfortunately our funding has run out for that portion of our project. But it was really beautiful. We had clubs run in over 40 different countries around the globe. And it was a really great opportunity for kids to see engineering and invention in different educational contexts, and to see that, you know, tools might be different, solutions might be different, but we're all countries that have problems, and engineering is a really successful tool at addressing all these projects. Oh, please create activities for younger children, kindergarten to 2nd grade. Okay, we'll try. Yes, we will. Again, we will send out the presentation to everybody who registered, and we will be happy if you forward that to anybody who missed the presentation.
Somebody asked if there's a competition for the students, and we find that competition can be a tricky dynamic, and it cuts both ways. The design process, encourages kids to work at their own pace and try new things. And sometimes, if you're trying to optimize your design just for one purpose, it can cut down on that creativity.
I'm seeing, is there guidance on which of these activities can be done with families at home right now? That's a great question. I think first kind of assessing, maybe reading through some of the activities. I would recommend that Design Squad Nation collection on PBS LearningMedia and seeing which materials are more likely to be easily accessed by families. Some of them do involve like batteries and wires, which might not be readily available, but a lot of them, like I would definitely recommend Popfly is usually one you can have the materials for. Robert, do you have any other that come to mind?
Some of the ones that you'll see in the presentation are ones that can be done at home.
Mm-hmm.
And look for the one sheet that we have with abbreviated instructions and those are often good home ones too.
Oh, I'm also thinking our Inventing Green collection, a lot of those were intended to be created with recycled materials, so cardboard, water bottles. So I think those are usually an easier material lift for families as well. Are the TV show video episodes available for students and teacher viewing? Some are currently available on our PBS Kids Design Squad website under the video section. And I believe if you have Amazon Prime, you can get season 1 on Amazon Prime right now. The other seasons, I believe, you have to purchase, but I can double check on that and send that information out. Oh, the Strings and Things online simulator. So we had two, I know everybody loves that game. We had 2 games, Strings and Things, and I think Fidget Factory. Unfortunately, we had to retire them. Those games were created with Flash Player, and if you may not know, but Flash Player was retired by Adobe, and we unfortunately didn't have the capacity to rebuild those games on a different kind of player. So unfortunately, they have been retired. I know everybody loves that game. Okay. All right, I'm looking for more questions. Some great ideas in this chat box. This is wonderful. Oh, is there still a way for kids to upload their projects? On our website, you can still, with different projects under the build section, there are places for people to upload pictures of what they built at home. And yes, that is still a function of our website. Do you ever facilitate workshops on the road? We are able to provide some at WGBH in Boston, but we did just do a mini grant where we were going to have some other of our wonderful PBS stations do it, but unfortunately with the current climate, I think a lot of those workshops have been postponed or unfortunately canceled. But we will try to work more with local PBS stations in the future when it's safe to do so, to have more workshops in different communities across the US. Ooh, Robert, I just see this question. Do you have materials or suggestions on how to raise the level, something too appropriate for high schoolers?
Yeah, I think that these are great activities to start with the kind of simple recyclable materials that we suggest, and then that iterative process where they move into pieces of wood, kind of hardware shop, hardware store pieces of metal, things like that. Kids really want to progress in their process to materials that are more durable and can give a more interesting result.
I'm seeing another question. Is it possible to link materials using Google Classroom? Any of our materials that are on PBS LearningMedia have a Google Classroom integration. So any of those can be used with Google Classroom. I know a lot of school districts are using it now. Okay. All right, I think that is the end of our presentation. If you have more questions, please feel free to email us, and I will send out this recording and the chat box to everybody on. Thank you so much for coming. We really appreciate your time.
Thanks a lot.
Yeah. Take care, everyone.